It's easy to think that the decisions we make don't matter in the big picture. That is decidedly not the case here. As you choose a refrigerant and a vendor going forward, you impact not only your business's bottom line, but the planet's bottom line. You will make a difference. The sooner you make it, the smarter you make it, and the bigger the difference you make. We at Hillphoenix have the talent and experience to help you make the smart choice. It's hard to imagine a world without air conditioning or refrigeration, but the science and technology of refrigeration began only about 150 years ago. An early mover in the industry was Hillphoenix company founder C.V. Hill. In 1887, he started a tradition of innovation in the food retail business. As a grocer himself, he invented a cooler with a butter slide. Other grocers saw what he built and wanted their own. That was the beginning of a dedication to engineering great solutions that continues in our company today. We still design and manufacture refrigerated display cases, but we are now a leader in refrigeration systems, integrated power distribution systems, and we continue to expand into new industries. Our mission is to collaborate with our customers to drive great design and environmentally responsible solutions. Hillphoenix experience, expertise, customer responsiveness, and time-tested best practices position us to react to changes in the industry and the needs of our customers. Since 1996, our environmental improvements in alternative refrigerants and energy efficiency have helped take more than 2 billion pounds of harmful emissions out of the atmosphere. Today, Hillphoenix leads the industry with its Second Nature line of alternative refrigeration systems, which include glycol, CO2, ammonia, and hydrocarbon systems. The company has seen the evolution from natural refrigerants used in the 1800s to synthetics developed in the 1920s. Now we see a shift back to natural refrigerants as the environmental impact of those synthetics, ozone depletion and high global warming potential, or GWP, loom large. The ozone layer shields us from harmful solar radiation. And when scientists recognized the problem of ozone depletion and sounded the alarm, the world responded. In 1987, the Montreal Protocol, an international environmental agreement, established the phase-out of ozone-depleting chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs. That was followed by the Kyoto Protocol in 1997, which set further standards to reduce the carbon footprint of industrialization. That protocol mandated reductions of hydrofluorocarbons, HFCs, to curb greenhouse gases and their global warming effects. What does this mean for your business? As you prepare to invest in a new system, you will consider factors that impact your total cost of ownership. Obviously, environmental impact and compliance, or lack of compliance, are urgent. Impending restrictions and deadlines are approaching quickly. 3 sets of standards are important. The Environmental Protection Agency is concerned with both direct and indirect greenhouse gas emissions and their impact on ozone layer depletion and global warming potential. The EPA has continuously restricted the production and use of CFCs and HCFCs, some of which have global warming potential rates higher than 10,000. By 2030, HCFCs will be completely banned. The Department of Energy mandates that energy savings goals be reached by early 2017. Their goal is to use more efficient systems and avoid about 142 million metric tons of emissions that would be equivalent to eliminating 27 million automobiles from our highways. The EPA looks closely at programs like CARB, the California Air Resources Board, where regulation will require registration leak detection and monitors, leak repair, retrofit and retirement, reporting, and record keeping to help reduce high GWP refrigerants. Those regulations do not apply to natural refrigerant solutions. We at Hillphoenix embrace the goals of sustainability. We launched our first sustainable refrigeration solutions in the 1990s and are recognized for our leadership by customers, industry peers, and regulators alike. Experienced with a wide range of natural refrigerants, ammonia, CO2, and hydrocarbons, we can help you navigate the terrain ahead. Our formula for success is customer collaboration and deep working relationships with manufacturers and suppliers, which combine to create great solutions that push the industry forward. Today, we believe that of the environmentally responsible solutions available, a CO2 system is a superior choice for most applications. Carbon dioxide, or CO2, is a naturally occurring component of the atmosphere. It's inexpensive, readily available, non-toxic, and non-flammable, and it doesn't impact the ozone layer, so there are no regulatory issues when used as a refrigerant. As you prepare to invest in a new system, we suggest that you future-proof your business by switching to a CO2 system now, with global warming potential grade of almost zero. Not only will you enjoy the immediate benefits of compliance with the new regulations, but you won't have additional downtime costs from multiple incremental upgrades. Again, a benefit to your total cost of ownership. Returning to the decision you will make, let's look next at the initial cost of equipment, installation, and charging of the system. Although the cost of equipment may be higher, we've been able to reduce some of those costs by incorporating less expensive materials. The initial charging of the system with CO2 is dramatically less expensive than synthetic refrigerants. Energy efficiency will impact your return on investment as well. For large food retail stores, our systems generally provide between 5 and 18% reduction in energy expenditure over traditional systems. Team engineering, experience, and our knowledge of the thermodynamic properties of refrigerants are Hillphoenix's sweet spot.
Hello, my name is Derek Goslin, Hillphoenix's Systems Product Manager. We at Hillphoenix continually improve and redefine our CO2 technologies. Our systems have evolved as we meet the challenges as things change. We started with secondary refrigerants, evolved into CO2 cascade, and now have introduced Booster, a 100% HFC-free solution. When we first started with propylene glycol, it was our first venture into secondary refrigerant, which allowed us to use a natural refrigerant within the store and retaining the HFC charge to just the primary system in the machine room. Some of the challenges that we had was there was no viable low-temp solution, and we had to add variable speed drives and end-of-loop controls to improve the energy efficiency. Then in 2006, we introduced CO2 as a secondary fluid that met the need for low-temp and medium-temp application. In 2008, we moved to CO2 Cascade. This allowed us to remove the HFCs 100% from the low-temp side by introducing CO2 direct expansion with subcritical compressors. In the combination system, that would have DX for low temp and secondary CO2 for medium temp with one medium temp primary system, further reducing the HFC charge in the system. In 2010, Hillphoenix acquired Advancer. With their experience and technology, it allowed us to introduce CO2 transcritical design into the North American market. Today, Hillphoenix is the global leader in transcritical installations.
We made another leap forward when we accepted the challenge of designing a CO2-based air-cooled system where the outdoor ambient temperature is often over 80 degrees Fahrenheit.
We are here at a CO2 booster installation in the greater Atlanta area to show you that a CO2 system is very comparable to a traditional HFC DX system. The term booster references the fact that we take the discharge of the low temp compressor and dump it into the suction of the medium temp compressors. On the low temp side, you can use semi-hermetic or scroll compressors. Here on the lead compressor, we have a digital scroll. That is used for capacity control. On the lower compressors are the medium temp compressors. That lead compressor also has capacity control with a variable speed drive. That is a standard on a Hillphoenix Advancer system, but is an option on a traditional HFC DX system. We also have a rack controller, which is traditional with any parallel system. Here is the Emerson CPC controller, but we have also done them with Danfoss and Microthermo. The system is piped with steel piping to handle the pressure on the high side. We will soon have approval with UL to use high pressure copper that'll help us lower the cost on the refrigeration rack, but also that of field installation to the condenser piping. The system has a high pressure oil system, which includes a coalescent oil separator and a reservoir. Some of the items that make a CO2 system different than a traditional HFC-DX system is the high pressure control valve, which is used to control the pressure in the condenser gas cooler on the roof. We also have loop piping. That helps to lower the installation costs versus individual circuits, and then also provide a pressure relief manifold. That manifold allows us to properly vent the piping to the exterior of the building to meet local codes. Now, let's go on the roof and look at the adiabatic condenser that allows us to operate this system in a warmer climate. Now that we're on the roof, one thing to consider: in a cooler climate, air-cooled condensers are sufficient in doing the heat rejection process. But in a warmer climate, it is required to use an adiabatic condenser. But as that heat rises, we can then inject water through the adiabatic pads, allowing the air to drop in temperature as it crosses the pads, helping to improve the efficiency of the condenser in a warmer ambient.
At the far end of the map, as we move to a colder climate, Hillphoenix was awarded the Harry J. McDonald Recreational Center contract to design their ice rink system, a different industry and a different climate.
I'm Tim Henderson. I'm the Industrial Program Manager for Hillphoenix. I've got 25 years experience in the refrigeration industry, and we're here today at the Hillphoenix facility in Conyers, Georgia. The citizens of Anchorage know a lot about ice and cold. They take their ice arenas very seriously. They were faced with two major problems. One was to replace the aging infrastructure of their current ice arena system. The second was an environmentally friendly solution to deal with the recent EPA regulations on synthetic refrigerants. They came to Hillphoenix to help solve both of those problems. The CO2 direct ice rink system that we design and build here in the USA starts with liquid CO2 under the ice surface. We remove heat from the ice surface into the liquid carbon dioxide. We return that back to the refrigeration skid. Once at the skid, any liquid CO2 drops to the bottom of the vessel. Off the top of the vessel, we take the vapor CO2, we compress that. Once we've compressed the CO2 vapor, we go through an oil separation system, remove any oil carryover from the compressors. Now the heated vapor through heated compression, as well as the heat removed from the ice arena system, goes to a heat reclaim system. There we remove any heat we find useful to be used in the arena, be that to heat space, heat water, or even melt ice from the resurfacer. Any heat not used for any of those three operations goes outside and is rejected to the atmosphere. Liquid CO2 returns back to the vessel and is again pumped under the ice surface to remove more heat in this closed loop process.
John Rhoda is Director of Parks and Recreation for the Municipality of Anchorage.
So one of the things I learned over time was trying to find the best management practice as far as maintenance, monitoring energy consumption, making sure we have an environmentally friendly system, and lots of things that I learned over the last 40 years led us to this technology, led us to the conclusion that this is basically a self-contained system. It is low on maintenance. It is driven mostly by computers. Big change from my earlier years, but we also have the advantage of remotely monitoring the activities. The overall performance just in the last 45 days since it was turned on really has shown us that this is the way to go.
Local Anchorage contractor Colin Zemansky took charge of removing the old system and installing the new system.
Hillphoenix gave us everything that a manufacturer could give you. The operators feel this is probably one of the best sheets that they've ever dealt with. The water freezes quicker, more even when they're doing the resurfacing, and just overall, the operation seems to be running better than they had ever experienced before.
But the bottom line is that we think the system that's being provided, being installed, currently in operation at the McDonald Center gives us the best of the new technology, longevity, low maintenance cost, energy savings, and I think we're going to be very satisfied with our selection.
In summary, Hillphoenix CO2 systems offer a full complement of advantages. Significant HFC charge reduction with CO2 secondary and cascade systems, and 100% HFC elimination with CO2 booster systems. CO2 offers improved compressor energy performance. Smaller diameters reduce copper pipe usage. Eliminate future refrigerant retrofits that interrupt sales floor activity. Much smaller carbon footprint. CO2 is naturally occurring and delivers a GWP, or global warming potential, of 1. CO2 refrigerant is abundantly available and inexpensive. Sustainable technology helps achieve Green Chill certification. As you choose a refrigerant and a vendor going forward, you impact not only your business's bottom line, but the planet's bottom line. You will make a difference. The sooner you make it, the smarter you make it, the bigger the difference you make. Hillphoenix, the smart choice.